Hi everybody, welcome to the stream. Alright, let's continue with refactoring our game effects system with the new standard visit function. So, one thing I want to address, and this was brought up yesterday and I kind of thought about some more and thought, okay, one of my viewers mentioned that you can use templates here, to generate the, functions. So what I mean here is, we're currently using macros, right, to generate these two operator, parentheses functions, function operators. And, I was thinking more about it. I'm like, wait a second. When we're calling, the update effects, loop, we're essentially saying the type is a standard variant, this, right? So who's not to say that the templating engine or the compiler doesn't want to generate all the functions for each one of these types, right? So I spent some time in Visual Studio just rewriting my little example code that had different versions of the function here. Can we not? And when I did this, I made a struct overloaded with a template operator function, which means that it would get created for any anything that needs it. So we just put type T for object instead, and obviously whatever overload we're interested in. And I ran this and it actually generated all the functions and it worked. It works just fine. So if I were to run this, we get our AABCB. I guess it's just smart enough to know that, hey, standard variant does produce these. So that made me realize, oh, okay. So let's just switch from macros to templates here, and we don't even have to write all this anymore, which is kind of cool, right? So we're going to be doing that. So let's do that first. So first we're making this a template with type name T. And then in these two, we get to put T here. And it's going to create a draw and update overload for any single type that would need it. So this would be the result of that. At least in theory, right? So, unrecognized type name? No, that's right. Get rid of that. And in theory, this should work. This should be all we need to do in order to get that. Now, it looks like the template doesn't transfer over to here. I have to do it for each one, and that's fine. I guess we'll make it that way. And then they both exist. So I think that's really cool, a cool idea, and I think it actually works out in our favor. So now let's go back to where we were yesterday. We were creating a for each here because we found out that originally all effects are drawn from back to front, right? If you think of the game, everything that's farther up on the screen needs to be drawn so that it is behind everything, and everything further down from the screen needs to be drawn in front of it. So we have to order every effect that's currently active based on that information. So what I'm doing here is I'm iterating through all effects to find out which effect is currently active. So that's why we're active foregrounds down placed back here. After we've placed all the active foreground effects, we then need to sort all of them by Y. So it looks like in the past we just did that by using the Y positions. I think I deleted the code because I committed this yesterday just to be safe. So in order to view the diff, I would have to go ahead and view our history. So yeah, this was from yesterday, and we can look at specifically adventuresinlastoria.cpp and any changes that were made for it. And that's not right. Can I get the proper file, please? Here it is. And we go to around the line where it says populate render lists. Render, and we can see here that in the past we did a view filter Let me see. Okay, the view filter was for on upper level or not. But then we also did a sort. Like, we did the sort in populate render lists. Let's go there. Populate render lists. Okay, yes. So before we had sorts where we did position Y is less than other position Y. That means it ends up being behind it. As in, it will be first in the list. It'll be rendered before effects that are further down on the screen. That way we have the sort of like depth going on there. So that's what we have to do next. So essentially just standard ranges sort here on whatever effects are active. And we're gonna use, so we've been populating active foreground effects, so that's the one we're going to sort. Sort is a binary comparison. So we're gonna have two effect datas that we're gonna compare. Effect 1 versus effect 2. And we return effect1.y is, or effect1.effect, because it's stored in separately, dot. So this is an optional, so we do have to extract the value from the optional, because we already determined it's active, so it should definitely have an item available to it. At least this should be an optional. Am I thinking of the wrong thing here? I swear we made it an optional. Let's see. Oh, it's a, yeah, it's an optional, but we get an effect T, which is a variant. Hello, welcome. Welcome to the stream. Let's see. So since it's a variant, the way we would sort this would be interesting, because it's going to have to generate, like, a template function that would effectively give us what the Y position would be based on its type. So that makes me think, okay, well, if we're gonna do that... Yeah, this doesn't make it easy, does it? Like, effectively, we have to put the effect in here, not the effect data. Oh wait, we did. Okay, so active foreground effects is... This is the optional. Let's put in the actual value. But like, to even get that far, it's a little confusing because you would have to know the type. Like, how do we get away from this like type dependency here to get anything related to the function? It's interesting. We don't know what the type is here. Like, there's got to be something we could do here that we can, like, connect together to say, hey, grab whatever this effect is and do its thing, right? Like, that should be the goal of the effect data, is it comes with something to automatically convert the effect type for us in some way. At least that's what I would like it to do. I'm just trying to think here. Okay, so what can we do for this? We could make another, like, standard visit function. I guess that would be okay-ish? I'm just trying to think, what else could we do here? We could also just try to template it out, because this is a variant, right? So it's like, can we generate the right thing here? Like, I'm trying to think, how would we go about this? Depending on what the effect T is, it determines... what, like, let's say we're trying to get the Y position, right? Like, get pause or something. Say we wanted that information, but we wanted it accessible from here. In theory, right, we could make this a template function, and then the compiler figures out, hey, I'm going to use this type T to generate a function called getPause appropriate for every single type, right? And if we do that, then ideally, based on the type, like, we can auto-deduce the type from the variant and get something that figures out what this type is and then does stuff with it from there. Like, that's what I'm trying to think right now. How do we go about generating that? It's like, get pause of what? This? But this would be of type T, so the T would have to be like an effect of some sort. Don't know how that would work, because how do we use the T here to get what we want? That's the confusing part right now. So is standard visit gonna be required again then? I guess it would have to be. So like, do we make another overload just for that? Then I was thinking, okay, well, if we're gonna make another overload for that, do we have to provide another, like... We have to provide something to differentiate everything by. BitBaron says, yo, how did you learn CPP? Started with CPP till chapter 7, but so boring, so I don't know if I should really continue or start a project. Chapter 7, I guess, in whatever book you're using. I don't really... The way I learn programming is not by reading, I just go by doing, and I think that's a very valuable insight to realize, is that you just need to actually sit down and start using the language, right? Reading and absorbing stuff doesn't get you doing like you need to be doing. For me, when it came to C++, I was very inspired to have something like simple and easy to work with. So there's this little engine I use, but it's really just a library called the OLC Pixel Game Engine, which is written for the C++ language, and it's very similar to, like, if you know Raylib's like a C framework to let you like draw things on the screen. Well, the OLC Pixel Game Engine is kind of similar to that, but for C++. And the biggest appeal to me, and the thing that I think is very great for beginner C++ programmers, is it allows you to just grab this header file, like you can literally copy paste it into a new project, and then grab the example code that it provides in the comments, and then you literally just have something that works. Yeah, Raylib is very nice too. It's very well designed, and it's very easy to use, and the Pixel Game Engine kind of follows that philosophy as well. Even if you're not interested in like game development, being able to draw things on the screen makes things very visual and fun. So it can be used for like simulations. You can use it just to get something quick on the screen, right? Like I can literally show you from like the beginning here. Like if I were to start in C++, this is exactly what I would do. Open up Visual Studio, and by the way, I do recommend using a tightly coupled IDE. Like Visual Studio is very nice because you can just get the Visual C++ desktop redistributable or development and start building, right? I would just make a new project and I'll be like, okay, I didn't want to create in that folder, but whatever. And then I would literally just throw this header in my header files and start building, right? Also, I will mention that the OLC Pixel Game Engine also has like an online version that you can just try code if you really wanted to. And then I'll be like, okay, let me add the CPP file, which is like the, I'm just gonna call it main.cpp, which is where the actual code goes. Like, and then I'll throw in the code for the OLC Pixel Game Engine, and I'll grab the example found in the header and run it. And this is where I would start with C++, getting something like this running. I also have to turn on C++ 17. That is a requirement for the latest versions. And then it should compile. And I literally just get a bunch of pixels on the screen. It's probably making the screen really blurry, but that's basically the proof of concept, right? And then start messing with things. The example program is very simple. You have a couple functions you override. And from there, like, it's like, well, what do I do? Well, the first thing I would do is, like, with C++, anything you have, like, if you're using a library, is to look at the header file. And specifically what you're looking for is the functions you can use, which you'll find near the top. It's a little buried, but you'll eventually find the Pixel Game Engine class, which has, like, your things like grabbing key inputs, grabbing mouse inputs, getting information about the window, and then all your draw functions, which is essentially what you would use in order to get stuff on the screen. Yeah. And just in general, like, I would recommend doing a project. It doesn't have to be big. It doesn't have to be fancy. Not to say you can't start with a fancy project, but you're not going to get very far. You're going to get stuck very quick, and then what you have to do when you get stuck is make sample projects that explore the concepts you are stuck on until you mastered those, and then you go back to either working on your project, starting another one, so on and so forth. And you end up with all these like mini projects that you can just reference. So the idea is you make stuff, you make lots of stuff, you kind of just like get experience. You don't have to make anything. It's not gonna, a lot of your projects aren't gonna result in anything like any product. Your goal is not to release a product, your goal is to learn. So like you can see I have tons of repos. Most of these are C++ repos, and just of all sorts of random things I do. And even on my repository site, my self-hosted like GitHub essentially, like you can see I have hundreds of projects in here of things I do. So I guess one of the key takeaways is that if you're going to learn programming, no matter what language, you need to throw in time into make anything, make everything. And I made like thousands of example projects and test ideas and things, and that's really how you discover and learn programming. And also, if you are going to be doing like a specific project, like you'll notice a lot of times while I'm programming, like I've pulled this up multiple times even today, I have an example project, and it's something I can pull up to say, I need to test some concept, I just have it ready to run. So I already have the structure of the OLC Pixel game engine in here, and you can see there's a bunch of like random stuff in here, because I use this file all the time to test things, test ideas, test concepts, test new things I'm trying out. Same idea, right? And it just makes it really easy. I just cleared this and put whatever I want to run in it, and then test stuff. That makes it really easy to jump back and forth between like what you're working on and what you're trying to solve. Speaking of solving, I gotta figure out how to solve this now. So thinking a standard visit for this would be necessary, but like how is that gonna work? Because even if we standard visit on something here, we've gotta like return the result, right? So I guess I never looked at that, but the standard visit function that we call should have a result in it, right? Like when I wrote it, did I not handle the return value? I don't think I did. Oh, but it does say bool here. Okay, but what is that bool? I don't think it's the return value. I don't think it auto-deduced that this is the update function. That wouldn't make sense. Like, let's say we get a return value. What would we do with that, right? Or maybe it does deduce that. Let me see. So the return value is the result of the invoke operation. The return type is the type obtained from applying decal type to the result. So in this case, it figured out that this, okay, because this is the overload, so it figured out it matched this function, which means the return type is a bool. So standard visit will dynamically deduce what the return type should be. Okay, that's really good. So that's useful for us, because in our case where we're sorting right now, we need to return a boolean if we do a standard visit using this concept. But in order to figure out the overload for it, I'm going to need to provide something that indicates, hey, this is what we're looking for, right? So, I mean, I could make another struct that's just called, like, get pause overloads or something, which might work, but then at the same time, it's like, what else could I do here? This is interesting. We could, like, this gets really interesting, because we could do something like this, right? Let's say we wanted the get pause function of any given effect, because we know that exists. Like, I know that exists. If I were to throw a get in here for any effect, we should have, like, oh, and this might be the way to go. This is another way to handle it, huh? We could just standard get as an effect. Can we do that to downgrade a class though? I don't know. That would be interesting if we could. I didn't think about that. So if we did that, every effect has a certain number of members. Like that's just expected. And I think, okay, well, pause is an actual member. I don't see get pause, so maybe that wasn't a thing, right? But that makes me wonder, does the standard get... I don't think this would work, because as far as I know, standard variant has an index for every type stored in the variant. If the index is wrong, it won't convert. At least that's my assumption, even if it's like a child class. So let's test that theory real quick. Just to make sure, like, we didn't find some, like, loophole, right? So we have objects A, B, C, B. And let's say inside the functions, instead of doing standard visit, we're going to do something like standard get A, because they should all technically be a class A. Actually, I think I removed that recently. No. D is not a class A, but we don't have a D in the structure. So standard get A on our object, and we're just going to say dot print me, right? Every A has a print me function. So if we convert it to A, will it crash when we get to the B object? That's the question. If not, I just expect them all to be A's. So it does crash. So we did expect that, and I assume the crash, let's look at the call stack, is due to a bad variant, and indeed it is. So that doesn't work. So we're gonna have to do a visit. That makes sense to me. I just want to confirm that. Like, internally, I understand what a variant is, so the explanation for why it doesn't work makes sense here. So we're gonna instead go for something more like this, and I think for now we'll just do like effect overloads and add like a special, and I hinted at this the last time I was working on this, a like effect command. If we make a list of commands and we specify a particular one, class enum, what? If we specify a particular command, then we can use that as the overload to determine what to do? No, that's not necessarily true, right? Because it'd be like... Oh, sorry, flipped these two. It'd be like, I'd be making a name specifically to define a different overload type for this. I feel like that's a little convoluted. Like, I either make a bunch of structs relating to different functions, or I put all the functions in one place, but then the overloads have to be accept different things. Or I could make it on the fly. Okay, now there's an idea. Why not just make it on the fly, right? I like that idea. Okay, for something simple like this, I think it's better to just make the struct inside of here. So we're gonna make a new struct. I don't think it matters what it's called. Let's just call it like... I think you put the keyword struct at the end, but you put the name... I forget. Let me look up struct syntax, because it's like, if you're defining a private... I think it's called a private struct. You can do it a different way than just... I mean, you can specify like this, but I think there's another way. And I forget what that's called, but... maybe I'm just thinking C. Like in C, right? You would put it at like the end. So I guess that's C syntax. Let me take a quick peek. A compound type. Wait, this is the same thing. It took me to the same page. C language. Oh. Well, we want C++. Hold on. Unless they're the same. No, they're... I don't... C++ keyword. Declaration of a compound type. There's enum struct. And struct. Wait, what's an enum struct? Scoped enum. Oh, that would be like an enum class. Same thing. I just got confused because it's like enum struct. Okay, so the syntax for both in C and C++ is the same, I guess. Yeah. At least in this scenario. Because I was thinking there was something you could do like struct something, right? If I called it like struct A or something. But I feel like that's more, or just struct. Something like that. Anyway, if we just do struct, what's this, like, compare pause? I don't know. I could give it a meaningful name, but it doesn't really matter. Then, type name is not allowed. Let me think. Can I just write that? Does that work? It doesn't know what that is though, right? You have to like define it. So I would probably just put it in here. It'd be like a struct compare pause. I feel like there's a way to do this all inline though. Maybe I put it afterward. It'd be like this maybe. Let me check one more thing then. Because I'm pretty sure I can inline it. Because when I first was working on this, we wrote the keyword overloaded, and this was a template that looked like this. So it like generates it like inside in theory, and this was like a template struct before. And I got it from CPPRef under the visit example. Yeah, so like here's overloaded, and here's the template for that class or struct. And it just writes it out right there. So it's like, it is what it is. I feel like there might be, like, I could probably end up putting a macro or something that might make something like this more sane to write instead of having to write something like that every time. Yeah, we could definitely compress it because it's like writing all this to get the position of an effect is a little ridiculous, in my opinion. At least when we're iterating through the list. Like, to get anything out of it. So, to me, that is quite excessive, right? So, standard visit. This is going to return the boolean we're interested in. This is going to be, t object, which returns object.pause, which is the effect. So, it's going to look something like that. And I guess it's going to be const itself. This is going to be a bool. So it'll end up looking like this, I think. A template declaration is not allowed here. Why not? This is inside a struct, so I don't think that's wrong. Let me try building and see what compiler says about this. But it would effectively being this versus this, right? It'd be one is less than the other. Well, I guess we're comparing the y's. Wait a second. Oh, that's interesting. Yeah, we're comparing the y's. So this would actually return a vf2d from .pause, like that. And then this would be the comparison between effect 1 and effect 2. I assume this has precedence over this, by the way. I've just been writing it like that. I hope it's not the other way around. But yeah, brainstorming, like, an idea for a macro where we can say, okay, if we have a certain member or member function to call, we can just write that as like the argument to a macro, and it generates all this boilerplate for us, so we don't have to write that every time. That might be the way to go. But yeah, inside of my example, let's say we have something like this. This is just easier to do stuff in because the compiler's not freaking out. So I can just focus on this. So this will return like an int of whatever the object's number is. This will return the object itself. That would have been an optional before. And yeah, just as a template declaration is not allowed here. I guess because this is a lambda, like this is generated in code, so this isn't a class that's generated at compile time. So that's the issue we're having, is like we can't generate this inline. Okay, that makes sense. So whenever we want to do this, we have to generate a function outside. That gets me thinking, if we need to do this, like that's going to change effectively how we handle like the effect type as a whole. So let's look at effect types.h. Let's say we wanted to implement a get pause here. Would it now make more sense to make a something like this, where we have It kind of would be, right? Like, let's say we had the, a compare pause struct, I guess, if we want to call it that, right? And we provide that here and say, okay, this is going to return object of pause. That's it's only a job. So if we have the struct inside here where it's relevant to like an effect, I think that would make the most logical sense. And then you would create a type of effect compare pause here. I'm just trying to think how I would lay out this code, right? So that's the idea. And that would work. It's a little insane, but like, this would be the struct used for returning a position. So would I call this like... This is where I get confused, because normally this would be like a function, right? It'd be like, is this now going to be a struct called getPause? Like, that's fascinating, right? I like that. That's very fascinating. That's what it reduces down to, and that will compile. But can we reduce it even further? Like, let's say all I want to write is like, in the most ideal scenario, I think it would be something like effect get pause, right? Provide the effect itself versus another one, right? Like, write it as if it were a member itself. I think that would be the most ideal situation, or another way would be like effect get. Maybe like effect get or something, right? And provide like something, because the common thing that's going to happen here is whatever is here is going to change. So if that turns into like a macro or something and you provide that item, then I think that's more or less what we're interested in. Looking at you makes me want to learn how to code too. It seems the stereotype that many trans people are into coding is actually true. Oh. Well, yeah, if you like making computers do stuff on your whim, or you like solving like logical puzzles, well, programming is kind of all about that. So it can be a really fun activity for your brain. Definitely keeps the noggin sharp. I'm glad it inspires you though, that's cool. Alright. But like, are there any problems to this? So basically, I'll be writing a macro to generate... No, because you can't do that, right? You can't like create template items on the fly. So that wouldn't work. Okay, so that option is out of the bag. So I think this is our next best bet, is something like this. I would even go a step further and say this should be a function and the standard visit should be abstracted away. I like that more. So struct getPause instead will be getPause, and getPause itself will have all the visit stuff inside of it. Given now I have to tie like a struct to this idea. Because the template would have to generate stuff based on the variant. That's the thing. Yeah, so that makes sense. So we have like a getPause struct. I assume we can't have a function called the same thing as a struct. Can we? Oh, maybe we can. Okay, that's fascinating. This is news to me. Alright, let's take a look. So I need to go under effect t.cpp. At least I should have that somewhere. Effect types.h does not go where I need it to go. Is it still effect.cpp? It's not. Oh, it is. Okay, yeah. So in here, this is going to be a vf2d effect getPause const. So in here, we're going to do our standard visit, right? That's the whole idea. So now we do essentially this, but in here, and whatever the effect is, that's going to be provided by our current effect. So It's just, this just returns pause, right? And, okay, how does it, so this doesn't know it's a struct. How would I specify that now? I have to do this? Type name is not allowed. Can I do something like this? Or is it just lost forever? Okay, what about using? Can we use it at all? So using get equals effect get pause. Like, it seems like the struct definition is now gone. Yeah, I don't know how we can reclaim that, because it's effectively gone now. It doesn't let us use the keyword struct in here. So that really doesn't work. Instead, it would be like get pause overloads. Like, I would just put whatever the function name is, followed by like an underscore overloads. And that would effectively do the same thing. Then this would accept the reference to this, and then it'll figure it out from there. So standard visit on here, t_object returns object.pause, which then returns here. So const effect. This needs to be const, I guess? Would that end up resolving it? No. Oh, nope. IntelliSense did update, though. Well, even if we take away the constness, let's see what happens. It's like, why doesn't... Oh, I did that wrong. Why doesn't this deduce? I must be thinking this incorrectly. So... go through overloads using whatever the effect was. This is the overload it should generate. But how does it know what it generates? That would mean get pause the function itself would be a template function, right? Like, that's what I'm starting to think. Like, this and this are both template functions. And the get pause is generated based on what type is required for the overload. Now that's interesting, right? Let me see. So, but then we shouldn't need to do that in theory, because, let me see. Let me just think about this for a second. So, in this scenario, this function is now going to get generated on the fly with a given type t. The t is going to be deduced from whatever the type of this is. I don't know if we know that, though. It would be like, how does it know? Would I put, like, t is something? Like, I could specify it as, like, the decal type or something? Like, that's what I'm thinking, right? Something where we have to figure out the value ourselves. I don't know if this would be able to figure it out, like, unless we specify the type in it. T is like int in this case? Yes, but the way I want to use it is like this. I don't know if the T will be able to if you'll be able to figure that out from that. It's like, but then I'm just calling it like this, which is ideal, but I don't know if this is the way I want to actually, if it can actually figure that part out. So like, it wouldn't even be like this. This is for a variant. Like, this would have to be like static or something, which is even more silly, because otherwise there's no way for me to get to it by default. It's like effect get pause, right? That's what I'm starting to think. And then this would be the effect we're interested in, which then gets passed into here, like so. Okay, it made a get pause itself, but it's just, this is just normal. Like, I don't know if this, yeah, this T isn't getting specified, so I guess if this T was, if this was a T, then that would work. Then it would be forced to figure out the type from there. So now this is like, this is whatever it's supposed to be now. Yes. Template. I do know how a template works. Thank you. But trying to make it work for our situation is a little more tricky. At least. So if what I've done is correct, then we've just generated a function that returns the position of an effect given we don't know the type of it based on the visitor function. Which means that the syntax becomes this. In theory, because the return type of the visit function is a VF2D, so we've essentially made it so we can, at least if we provide this kind of boilerplate, we end up with a function that returns the position of any given type in a variant of that we specify. That's an interesting idea. Now I wonder... That's the theory anyway. I don't even know if this compiles, so let's actually check that first. But that's interesting. And then I want to see if I could take a step further and we can like get all these like get pause keywords or something and substitute them and turn this like 7-line boilerplate into like a macro. And maybe this will be a lot more usable, because this is a lot to just make something like this work conceptually. But maybe we can make it work. Like a 2-argument macro, one is like the name of the function, and the other is what member or member function is trying to reach into. I think that would be the ideal scenario. But that is a lot more template generation than I was originally expecting. But it's this idea that we can probably like make everything more generic and we don't have to worry about, well, it's because we have a variant for every effect now. So it's like now we're committed to using everything as a variant, which means we need to auto deduce what we're trying to call every time. So this is at line 1060, which is starting here. So it actually accepted this, at least so far. I don't want to proceed further unless I know this actually works. So I'm actually going to take one step back to our example, and I want to build something similar just to see if, just to prove the concept works, right? We're going to have like an example class. I'm just going to call it an effect class. The effect class is going to contain a VF2D called the position. And we can just make a couple of these for fun and put them in a variant structure that holds effect. We can have a couple of example effects that are derived from an effect just to test. So effect A and effect B, both derived from effect. Maybe they do something special, but for now, we're just using them as different types that actually refer to an effect type. And so knowing they're different types, we don't actually know what the type is, but we're putting them all into a variant so that no matter which one we use, they're all there. And then now that we have those, let me make a set of objects that actually work here. And I'll just change that to a normal effect. They don't have a default constructor. Let me just initialize these with different values. Like one can be 0, 0, one can be 1, 1, one can be like 2, 2, right? They can all be different values. That way we can just differentiate between all of them. They all need to have, I think, VF2D specified. Either that or the default constructor is deleted somehow. Now convert from VF2D to effect. What about effect itself? Okay, well, let me just make a constructor, I guess? I feel like because it's a struct, it should have like a default constructor, but maybe it doesn't work for a variant. So a default constructor for effect would look like this. Setting pause to pause, and just providing that as an argument. That doesn't seem to work for some reason. Why? I literally added the constructor. Unless I'm tripping. I don't know why it's actually doing that right now. But like, even without this, it should default to creating a VF2D. I must have done something silly. We just try creating one outside of here. Like, effect A, right? Oops. No instance of constructor matches the argument type. Okay. So we just say it's a VF2D. Let me see what compiler thinks. That might help us. Okay. Struct type redefinition? I already made something called oh. Okay. I had something way up here for testing. Oops. Okay, well that makes more sense. That was my original testing stuff. So let me get rid of all this junk actually. Now that we're not doing any of this. Okay, that makes way more sense. No wonder nothing was working. Okay, so now these all get initialized proper. And we have our object, right? So we're gonna iterate through our objects. And the idea was to test and see, okay, if we have like a get pause overload inside the effect class, can we make it so we can actually reference that based on the position or the get pause function? In this case, it's a static function that we made. So I think for now, I'm just going to return, or I'm just going to print out what it would be. So we'll do we'll do effect get pause on obj, and I guess we'll just print them out. So if we did it right, or if it actually works, we'll get the positions of each of our objects, and they are in order, so we should get 0, then 1, then 2, then 3, then 4. Then 5. 0, 1, 2, 3, 4. Wow, I'm kind of surprised that works. Okay. Okay, good. So we have a way to define a variant type with multiple different types and have it generate code that works globally across the entire type. Okay, that's very useful. So the next step would be to make a macro that kind of condenses this a little bit. So like, I would call it like create variant, and it would be something like this. Get pause would be like the function name, right? And then the member name itself would be pause. So then we'd be able to write everything we wrote there inside the macro. So it looks something like this. That's what I'm thinking right now. So let me just add new lines. So it would look like this. So then this all would condense to create variant get pause, followed by pause. Instead of whatever I put here originally, which was the... So this would be like function, and this would be member var function name. And in theory, that's what we would end up with. Something that looks like this. Maybe I'll even go a step further and make this be specified? I don't know. Well, we would also need to like have the actual like return type and stuff. So maybe we can generalize this a little more. Maybe like make it more flexible, right? We need to know like the arguments and the return type. That much is clear. So maybe it's gonna look something more like function, or function declaration, I guess is what we're looking at for. Which would then look something like this. And then this would be like the return function, which would be all of this. I feel like at the very least, doing something like this would make it a little easier to work with. And just reduce like the overall boilerplate. That's just what I'm thinking in my head right now. And this would be just this part. Maybe not even the static, just the... this right here. Yeah. So that's what I'm thinking. Like this would be the result of that. And it would do the same thing. I think that's as simple as it's going to get. Get pause is not a member of effect. It should be. Let me see what this looks like. Oh. That's not right. Hold on. So I guess this would become... So how do I determine this now? So this is interesting. It'd have to be like the actual... Well, this would be called func name. This would be called get pause. But I guess get pause itself can be here. That's what I'm thinking right now. Like the fact I have to declare it or specify it twice is kind of dumb right now. Member var. This would be just pause. Okay. So that's what I'm thinking. Maybe there's a way I can reduce this and this. Like, I could separate the function I'm interested in by return type and arguments, right? Return type and args. That way I can reuse the name, but that specified the name, so it'd be like... It's like I'm dividing it up like this, which is kind of silly, right? I assume a struct cannot have these symbols in it. That would be very silly. Like, struct test 1, 2, 3. Yeah, that would be very silly if that was allowed. So that's not gonna work. I think I like this better and just being a little redundant about it. I think that's okay. That's not terrible. I think that's the best we're gonna get. So I like this. This makes it so if I write a new, like, function, at least it's a little less boilerplate, and I get the ability to grab basically any like, function I need in regards to this, like, generic type. Oops, that's not what I wanted. This is what I wanted. So we're gonna have a macro here called create variant. Why doesn't this work? Define is undefined. Okay. Alright, IntelliSense, you're being silly today. So I can delete these guys and just write this now. It can be condensed to one line. I don't mind that. I like that. That's not too bad. And then it exists here. I can live with that. I could definitely live with that. If we need to create other things that effects need to grab, this is the way to go. Going forward. I could definitely live with that. I wonder if we can take this a little further, actually. Maybe we just write a generic get effect. Then we won't need all that. Like, what if we just did a static function called get effect based on a variant? I think that makes way more sense, right? Then we don't have to write this every time we want to create a new, like, member function or variable. I don't have to make this every time. I just make something that gets the effect from the variant automatically. And then the rest is just deducing it. Okay, I like that better. So we could even use the create variant function we just made to do that. So get effect would return an effect reference of type T effect, and we would return the effect reference and just return the object itself. Okay, I think that works for a more generic way of handling this, right? So we write get effect, and then we write dot pause now, because now we get an effect out of it no matter what the type is. So then this can now be reduced, and finally we have something much simpler, I think. Okay, this is a lot better. This is, I think, the final version of it. Minus maybe a macro. Maybe we'll throw in a macro. We'll call it like EFF. I think that's nice. This would be the variant. And then we just return whatever we throw in there. So it's going to be effect, get effect, EFF. Or variant. Cool. I think that's all we have to do. So then we can just reduce this part as well. I like this. This is good. Okay. Alright, so that's usually, so what we just witnessed is usually what happens when I'm designing systems, right? I need to find a method that I can consistently use throughout my code base for the next however long. It needs to be as easy as possible to use. It needs to be generalized enough to use. And we have to be able to come back to the code base and not have to think too much about it. So we're trying to hide most of the implementation details away, right? As much as we can, so that we can focus on writing the actual code. So in designing these systems, this is the part that's usually very tricky and the most time consuming. It's like, how can I write this code so it's very easy to use? Because I could have just made it so I wrote this like struct stuff a bunch of times every time I needed something new, and we could have sat with that. But then what happens when I come along 6 months from now and I want to add to that? I'm gonna be like, oh, what is all this? I have to add this just to make it work, right? So reducing a lot of this down makes it easier to come back to in the future, where it's a lot more condensed and low maintenance. Okay, so we've done this for the foreground effects. Now we're going to sort the background effects as well in the same exact manner. At least we should, but I don't have a list for that yet. We were in the middle of figuring out how we're going to do this new variant system. So, have that. Go ahead and do the same line here, but for the other thing. It's for active background effects. That background effect list. And then that all remains the same. So then in here, we sort all the active background effects in the same manner. Now they're all sorted, we have to split them by upper and lower between each category. So that's what this next part's for, which I can just substitute with these and with these. So interestingly enough, I do 2 passes of this. It's not like it matters that much, because I'm pretty sure compiler could optimize. But what if we did it in 1 pass? As in, like, just loop through each, throw them into one or the other, right? Like, that's what I'm thinking. Instead of filtering, what would we be doing instead? It'd be more like... It turned into more of a, like, for each or something. Which I guess is fine. Yeah, it's like, why not just sort them into one or the other right away? I think I like that more. Just in the sense of it reduces the lines and makes it so I don't have... I still have 4 lists total, but now I'm not doing like 4 individual filters, which I just don't like how this is laid out. So I think what we're gonna do instead, iterate through each one, plus I have to redo the lambda anyway, and it's now gonna be const effect data going into here. And let's see, so so this is where this comes in handy now, because we can just say effect, right? Effect. Wait, do these know if they're foreground or background? Or upper? Yeah, they do. It's either on upper level or on lower level. So this is going to be effect, and we just say if effect on upper level. IntelliSense is desperately trying to catch up. Pretty much beat it to it at this point. I can't really rely on it anymore. Then return one or the other. So if on upper level, we put it in the active or foreground effects upper list. So this should be... Oh, this is a filter view right now. That's interesting. Okay, that's very interesting. Also, am I gonna have an issue with this? Because these are reference wrappers, right? Like... Oh, this should be background effects. If they're reference wrappers, then in here, these are going to be reference wrappers. Because we're on the active. So I have the wrong type specified here. It's gonna, like, compile fail. So just another step in the process, these would be .get on the a reference wrapper around the effect data. So it'd be f1.get.effect, and I think these go last, so we don't need parentheses around these. At least that's how I see it right now. Let me just make sure I'm not guessing, because we don't really have the help of IntelliSense right now, so I want to be as thorough as we can be. So here's member access, number 2 in precedence, and then here's indirection, number 3. So indirection is lower priority than member access. So that should work. So those are fine. And then in here, we're going to insert... So we're not really inserting into lists, it's more like we are filtering. So I guess that's why we did the filtering after all, because we wanted to use views at this point instead of ranges or creating new lists. It's just more efficient. Now I see why I did that. Okay, that works. So I guess in the end, this is what we're gonna have to do. Let me just grab one of these, put that in here. Actually, for all 4 of these, that's gonna be required. It's like sometimes I don't understand my past programming decisions, and then I try to supersede them, and then I get to the part where I'm actually looking at it, and I'm like, oh, that's why we did that. Now it all makes sense, right? So again, we'll do effect. These are reference wrappers of effect data. So we're going to use to dereference on it after we do a .get for the reference wrapper and a .effect to grab the actual effect, which is an optional, so that's why we have those. And then these are not pointers, so now it becomes like this. That should be okay now, I hope. Yes. Like I said, IntelliSense takes a very long time. So we're finally good on this. All this code has been converted successfully to the new effect data types. So now we're gonna go down here and look at what else we have to fix or change. So this used to be an effect, it's now an effect data. So we have to grab that. Oh, this is also an iterator. That's interesting. I now have to think about the types again. So background effects lower is part of a view, and we're iterating through the view. So this is to get the value itself. Then what was this for? I don't actually know what this one was for. But we know it's a reference wrapper, so either way we're gonna have to do .get, I'm pretty sure, to get the actual value. So that returns the const ref, and then we're actually trying to call the draw function of a given effect. So we're gonna have to do EFF on it. It's going to be E or asterisk E dot effect. And I've noticed we're starting to do this a lot, so maybe it's time to make something that actually handles that. Like, is this gonna be the way we use it most of the time, is as a data, effect data? I guess so, because I'm looking at the types, right? We essentially made the effect data class to be passed around to handle data. So I think it makes sense that this isn't converting a variant, but the optional holding the variant. That way we can just reduce the syntax a little bit. So then it would just be like that. Although that's only one change, like that doesn't really help much, right? Like, is that really a big deal? I can do that myself, I think. So I think this works fine. It's hard to say. We should probably compile it and actually see what compiler says. It looks like it's happy with it. So let's go down here, because I'm just trying to understand, right? Because we got like indirection in indirection, so it's like, what am I actually doing here? So this isn't a shared pointer anymore. This is now an effect, a reference wrapper. Reference wrapper. Also, I think a reference wrapper is very small, so I don't think we're supposed to grab a reference to it. I could be wrong, but I don't think it's that big. So we should probably not pass it by reference. Let me see. Let me go back up to the underscore draw real quick. The other one, please. Okay. So the auto won't tell me what it is, will it? Dang it. Also, I forgot I'm in the middle of compiling, so that's taking most of the CPU anyway. But yeah, I don't think a reference wrapper is that big, and I don't even think we should really pass it by. I wonder if... So one thing I like about Learn CPP is it does tell you a lot of like, you should do this, you shouldn't do this. So maybe we can check one thing real quick. I don't know if I'm going to be able to find this here. Arrays of references via standard reference wrapper. Let's see if there's any... Standard reference wrapper is a standard library class template that lives in the functional header. There are a few things worth noting. Operator equals will reseat a reference wrapper. That's the nice thing about it. Implicitly converts T. Get method can be used to get a T. To make things easier, the standard ref and cref functions were provided as shortcuts to create reference wrapper and const reference wrapper wrapped objects. These functions can be used with auto to avoid having to explicitly specify the template argument. It doesn't say anything about how to use them. Let me see what their code does. Okay, is there like a for loop somewhere maybe? It doesn't really say anything about like how we could use them in a loop, if we should pass by reference or pass by value. It probably doesn't really matter. But let me see, let's think about what the type is and see what it says about the type size. Because in my head, it's probably like very close to a pointer, right? In that sense. It's literally just holding a reference of some sort. And maybe some extra code that says like, oh, this is how I reset it or such. Reference wrapper. Will you tell me what your size is? 8 bytes. So 8 bytes is very small. Passing it by reference wouldn't really make sense. Yeah, it's literally just a pointer. So we don't have to pass by reference really. That's not great. So let's not do that. Well, here we're not passing by reference, but here we definitely would be. Okay. So pass by value. We have decided. And why is this complaining? No defined conversion from... Oh, it's effect data, not effect. Okay, yes, that would make sense. Then we do effect on e.get.effect. Dereference that, and we get a draw call out of it. So that's what that's gonna look like. I'll just hope that's correct, because I think IntelliSense will take a while to catch up to that. Similar for foreground effects lower. Yeah, we're deep in the rendering loop now, so we're at the point where there is a lot going on in terms of like everything in the game. Like, if you all were wondering how the game renders everything, this is the entire render function. This is what happens every single frame to draw stuff. There's a lot. This pulls together everything. And like, the bulk of it, or the gist of it, is that you have to draw everything in order, right? By depth. So everything has to be like depth sorted. You want to draw things on top of others. It's why everything is like spread out and a little more complicated than it would seem at first glance. It's like there's so much you have to draw in the right order. So again, this was dereferencing the iterator. So that's a reference wrapper, so we have to do .get on it afterwards to return the effect data. And I would even go a step further and do the effect reference here and just do EFF, right? Like, that makes sense to me to just do it right here, and then I can just call e.draw. I like that better. And maybe I'll do the same on the other call to it earlier, just for consistency. It was the foreground effects or background effects lower. Yeah, so we did that here, but we're gonna convert it to essentially this because that makes more sense. So I like that more. And then this can be a little simpler to look at. Okay. And we're gonna have to do this 2 more times, so I think I'm gonna bring this with me because I know we're gonna see it again. So let's keep going. So now we're here. We've got this as a reference wrapper to a effect data class. We're not going to pass by reference. And in here we do convert to effect dot get dot effect, convert the optional and call draw. And then right here do the same thing but with background effects lower or foreground effects upper. To make sure I get all this right. Okay. I think we're good. Let's hope we're good. I'm just gonna see if IntelliSense wants to kick in. No, we're not good. Oh, I have to change these. They're not pointers. And that should do it. At least we hope. Okay. Well, let's call a rebuild, and then we'll see what's next. So there's a couple more things we have to do on top of all this. The last bit is probably just making sure how we add effects, and probably a couple more syntax related things we have to change. So that's probably the last parts of this. This is still complaining? Maybe? Trying to think what could be wrong here. I don't quite see anything. So I'm not... Okay. Looks like it's happy. So I did those right. Okay. What else remains? Background effects, foreground effects, undeclared identifier. Right, so those go now. If we want to use these functions, we need to change all this. This is now an array reference to standard... they're actually just standard arrays of effect data, I think. Let me see. Yes, they're arrays of effect data, comma 1000. Effectively, this is just a different version of this, so maybe I should just reference these instead? Or move the functions into here, into there. The effect manager. I made these public on purpose. I guess that's what we want to do instead. So maybe I'll get rid of these functions and replace anything that used them before, because that makes more sense. Okay. What else do we have? Less than or equal to no conversion from float to float pointer const. So this is in relation to the lifetimes. Okay, so there's gonna be a lot of this. The lifetime, at least from an effect data standpoint, is now a pointer. So if we ever want to grab the value, we're gonna have to do something like this instead now. Unfortunately, the way I did this, I didn't have like a get lifetime function, so that's on me. I didn't do that. So everywhere that uses the lifetime member, we essentially have to replace with that now. Oh, and it's looking for lifetime for this member, not just in general. So that's what all these errors are pertaining to. Maybe that's a good chance to actually replace it appropriately, but we'll see. Cannot convert from initializer list to effect data. Line 365. Initializer list to effect data. Okay, so what is this about? This has to be a pointer now, so is the constructor accepting a value and then converting it? Okay, so the constructor is accepting, yes, a reference value and then converting it to a pointer, presumably. At least that's what it should be doing. So yes, lifetime gets set to the address of lifetime. I guess it's time to look at the actual template conversion and see what it did. So no overloaded function exists for this. Can convert all the argument types. But again, if I'm doing it this way, wouldn't I just do effect.lifetime here? And then set the lifetime in the effect itself? Does that make sense? That should make sense, right? In theory, although this is a variant, I think that's why. No, it's a normal effect. Okay, never mind. That makes more sense to me. Well, okay, we gotta be... yeah. We have to make sure it's referencing the effect parameter, not the effect member. Because, for those that didn't know, this would be potentially bad code. You don't want to do this. Assuming this was like an actual normal type, but like it's an optional variant, whatever, so it's a little... but like assuming this compiled, you don't want to do that because you have to make sure the initialization order is correct. There was an instance one time where I naively assumed that the order I specified these in would set the member variables in that order, but that's not the case. And you'll learn that pretty quickly if you try to use that. They're in the order defined in your struct, so it would assign effect ID, followed by effect, followed by lifetime. In this case, I did in the right order. But if I were to change this order, it doesn't change the order of initialization, which can lead to bugs if you're making these assumptions without realizing what is happening. So just something to watch out for, and things that have caused problems for me in the past. The only guarantee is that they're assigned in the order they are defined in your struct or class. Okay, well, let's continue. So cannot convert argument 2 from T to effect. Cannot convert. And this is from line... While trying to match T equals effect... what? When T equals effect, you cannot bind an L value to an R value reference. You cannot bind an L value to an R value reference. Okay. Well, this is an R value, isn't it? I wonder if this has like a... okay, it doesn't. Does that mean we have to like create it and then assign? Like I'm trying to think here. From T to effect R value. With T being effect. Called from what? Where does this get called from? Oh, it just says 360. It's just a general thing? There must be like something that's actually making it do that. I'm like, where's the actual call to this? Because normally with templates they'll say, oh, this line of code is making this call, right? So that's what I'm interested in. But okay, so before actually, let me stop that compile real quick, because I realized where's my break key? I think it's that one. Yeah, so I realized we don't actually need the lifetime here because we're gonna assign it. So I can get rid of that argument and just use it like this. I think that makes more sense. And then here, effect data no longer requires this, and we just have to specify that in the constructor now, declaration. So that should work better, because that will actually use the effects lifetime specified here, which you're supposed to define when you create that effect in the first place. So let's see what happens there. So I think we're getting closer and closer to the point where we're going to start seeing any errors related to actual templates now, which means everything at least on the normal code side is fine. So it's just satisfying the template engine now with whatever nonsense it has to deal with. But hopefully our implementation so far has been pretty, like, sound. We'll see where we're at. So far, it looks like we're just getting warnings. I do see, like, reasons. That could be errors. Yeah, I'm seeing a couple of errors. Okay, let's take a look. I thought we fixed the background effects thing. Oh. Oh, we should fix this part, actually. So reset level states. Anywhere where we originally cleared this, we're now going to clear in effect. So clear all effects when we reset a level. Yes, that's very important. Additionally, I should change this. We should make it so the effect manager class has a static function called reset, and specify any structures that need resetting in here, and then just call that function. So it would be effect manager reset. That way we have a little more control over what we're doing from inside a different function. So let me just write the definition for this function real quick. That's not needed anymore. So effect manager reset. And this is going to be real useful for unit testing too. We're going to have to call this whenever we do another unit test. So maybe we specify that somewhere else as well. Anyways, it's going to be a foreground effect list clear. No, it wouldn't be a clear. So this is interesting, right? We have to essentially invalidate every effect, because we can't clear the list. The list will always be available. Another interesting thing I need to do is make it so we can get a count of like how many effects exist. Risen Recon, thank you for the follow. I appreciate it. Yeah, so that's going to be a useful function too. I know in unit testing, we typically count how many effects are active, so having a like get active effects count would be interesting. So yeah, foreground effect list, the way we would clear this, is there like a fill function? There is. So we can fill it with whatever value we want. If we want, we can just reset it to the default constructor, which I think we made, and it's just a very like simple initialization. Let me make sure we're not doing anything stupid here. Effect data. Okay. Just default values, and default values, that's a 0. Let's just say that's empty, uninitialized, and that's null pointer. Okay. That way we initialize correctly. So I'm happy with that. So we would do the same for the background effect list. We would just fill it with a bunch of empty effects, effectively resetting everything. I think it would be nice to assert here. Get active, and this is where we would write our active effects to. Get active foreground effect count is not equal to 0. Will error because it should be equal to 0. What's the difference in using : and dot towards classes? I use to access functions in the class, but saw you using : So if you are using something statically defined, or you need to reference like an inner namespace, you use : So in here I have a static function called reset. A static function means that it's not owned by any one instance of the effect manager. It's just owned globally. So I would use that here. But if I had like an effect manager with the variable manager, then I would reference a local function. Like for example, this just has a member called background effect list or something with the dot. And you would do the same for like a function. You can call static functions locally too, if you want. Like that would result in the same thing, but it's a little more, it hides the fact it's a static function. So this is like the more correct way to make sure you know that's not like local. But also if you have like nested structs, nested namespaces, you have to specify them with colons to get access to them. That's why we have like standard cout. Like cout is a member that is inside of the standard library, or like you have standard find. Standard find is a function in the standard library, in the standard namespace, so you would have to access it that way. It's also a global function in the standard namespace, so effectively this is how you would call it. So hopefully that makes more sense, or that explains enough about it so you're understanding. And you can see in these, like, I just call like the dot reset here because the HUD overlay is an instance itself. The reset is a local function to the overlay instead of a static function. So that means if I made like multiple overlays, each one would have a different reset call local to it. So it just depends on your use case. It's not like one or the other is correct. It really depends on what you're going for. Okay, warning. The active effect count is not equal to 0. Reported as value something else. It should be cleared. Exclamation points. So let's use a standard format here and just fill that in with the value from that function. And we would do the same, but for background. So get active background effect count. I don't know if I need the word active. I think that's a little redundant and just takes up more space for no reason. So I'm actually gonna get rid of that and just have it like this. Okay. So obviously these aren't implemented yet, so we have to do that next. I'll go ahead and create them both now. Should be pretty simple functions to implement, and again we'll make them static because the effect manager is only going to have, well, the lists are static, so it's not like each manager owns a different list, so these are going to be static as well. These are going to return size t's, and let's go ahead and write those out now. Size t, effect manager, get counts, and just return. So to find out the active count, we can do it one of two ways. If we assume the only way to add an effect is through the add effect function, then we can keep track of the count internally that way. We just have to make sure nothing adds or changes the list on the fly. Which tells me that I really don't know if I want to make these publicly exposable. Like, the only way we should be adding effects to the list is via the add effect function. So I think if we make these private, let's just make public getters for these. I would feel a lot more safe about that, because then I can control internally what these effect counts are myself. So I can make a new static size t called effect, like active whatever effects, effect count. And then I can just return that, and I don't have to actually iterate through the list just to count it, because I feel like this function, at least the way I want to use it, is going to want to count every single time, and I don't want it to loop unnecessarily. So a static is a global that doesn't change between implementation. I use object-oriented programming but don't use the full aspect of it. Yes, a static anything inside of a class means that it will just exist one time and one time only, and is not tied to any particular instance. So it's more like a global version of that member or function inside whatever struct or class you put it in. Okay, so we are going to keep track of these, which means we have to keep track of when they are added and deleted. So I feel like this now becomes redundant, because if we don't count these manually, then we're just going to return the counts, right? Which is pointless because we have to reset the counts anyway. So reset will manually set these counts, but like now we have to check these manually. Like we have to actually make our a little like for loop and go through these. We could actually do a filter and just count that afterwards and see if there are any. And if there are, we just kind of we actually error out at that point. So we'd say like for and iterate through the list of, in this case they are effect data instances. So const effect data inside of these lists, which I need to grab from here, and we're going to filter them out using standard views filter, or we can just do like yeah, filter's fine. Once it finds one, no, we just want to find one actually, so it'll be we need one of the whiles, like take while or take one of. I think there's a one of, I'm pretty sure. Standard views CPP ref. For some things, it's usually recommended a setter and a getter, but some implementations I use a public variable. Yeah, it can really depend. When it comes to encapsulation, which is what that is normally pertaining to, you have to make the decision under the guise that, do I care what touches this and what doesn't touch this? Because that, like, protecting your classes, protecting your data from being touched unexpectedly is the most important thing. And if you as a programmer allow yourself to let anything touch any data, that's why globals are dangerous, then you can cause lots of bugs unexpectedly. So it's good to try to encapsulate data to the minimum possible use case, right? Restrict as much as possible. So I just want take while. I think take while, drop while. I think I want take while. Let me see. So take while says take while. So essentially we're just finding anything that matches this. Yes. So anything that was less than 2026 pops out here. So the moment we find one, while drop while view consists of another view skipping initial subsequence of elements until the first element where the predicate returns false. Oh, maybe drop while view is what we want. So drop while, what's the condition? Is space? Is space. What is input? Space. Okay, so drop while space. Wait, what? That's an assert. That's also an assert. Okay. Drop while I is less than 3. So we want to drop while the lifetimes are less than or equal to 0. Because we want to find anything that's not 0. Hi there, Tiger. Welcome to the stream. Today we're in the middle of a very large refactor for our effect system. We've been just hacking away at different compile errors, using a lot of fancier template shenanigans to refactor this effect system, and using some new tricks up our sleeves. So there's been a lot of sweeping changes in the effect system. You can see this funny macro we made. So yeah, there's a lot going on. After trying to make it so we can still use polymorphic behavior for any type of effect, we're realizing that's a lot harder to make it work without... Like, effectively, we are wrapping all of our stuff in a variant that contains all types. This is the variant. And determining what behavior to use based on the type, which is literally a visitor pattern, at least that's the concept. C++ offers what's called standard visit, and you can use standard visit. Do I have my example up? You can use standard visit to define what function should be called based on the type. So actually don't have it here. Can I have it here? We've turned it into a bunch of macro template automation, but essentially what it is you specify a bunch of functions, and then yeah, depending on what type the variant is, it matches it up, and then all you have to do is call standard visit, which then returns the correct type based on the overloads. So that's fancy and provides polymorphic behavior without knowing what the type is. It's not that new. It's C++ 17. 26 actually introduces a few more extensions to it, but nothing that hasn't been provided in 17 and 20. So we're going to use drop while, where we're dropping everything that is not returning less than or equal to 0. So return drop while lifetime is less than or equal to 0 for a effect data. I don't know if you were here when I originally initiated this refactor, Tiger, but oh yeah, this is a pointer. Effectively what happened was I realized that we were heap allocating for every single, like, particle effect. And that sounds really bad for a particle system, because if you have rapidly spawning and despawning particles, you're going to get a lot of syscall allocations per frame, and that quickly added up. So I was thinking we were going to try a workaround where we have a stack allocated array that kind of functioned like a weak pointer system, in that you basically can take a reference, at least anything that wants an effect from the array, takes a reference from it, and essentially holds onto that. But the effect reference contains data about what the slot and effect ID is, which is a global numbering system that goes up every time an effect gets added to the game, so that if an effect gets replaced in any given slot, the effect ref will know it's expired. So essentially you can see we have an expired function which is inspired by a weak pointer system, a weak ref system, and now this is a fixed size. So that does mean we could hit a limit on the number of effects. I just chose a number that we're never going to hit, and when we add an effect, which is now part of this, the add effect function is also a templated function now, wherever it is. I don't actually know where it is right now. Oh, you know what? That's still in Adventures in Listoria. So the add effect function is now a templated function, so we can insert any type of effect. We're still using the R value system to prevent it from us creating additional effects where they're not supposed to be, inserting them into an empty slot. So this will search for an empty slot. It does a drop while as well, and then inserts it into that new slot, returns an effect ref for us to use if we want to use it like the old system. What's the font you use for the editor window? It should be the default for Visual Studio. Let me take a look, because we can look that up real quick. Actually, there's an easier way. Window, Tools, Customize. So if we go under... No, this is Commands. Sorry, I was messing with this a few days ago. Font. There we are. Fonts and colors. That's the window I was looking for. So we are using Cascadia Mono. That's what the font is called. Everything uses Cascadia Mono inside the editor. I think it's just the default for Visual Studio. If not, it's very close to the default. Like, because the theme I use is called Mystica Dark Theme, so it might have changed it. Who knows? I don't know. Anyway, so yeah, as you can see, this is a pretty big overhaul and lots of sweeping changes to the initial system we were thinking about. Also, I still have to implement the add effect with foreground and background, so I guess that's easy enough. Just return... So let me see, is the wrapper updated to the right type? No, they're still using weak pointers, so we now return an effect ref, so I need to change those two usings. I might as well do this now while I'm here since we're talking about it. And then we just return a standard pair containing both items. So return... Oh wow. Return add effect, with one being the foreground, so back will be false. And the second one, back will be true, so this is foreground effect. And then the other one will be background effect. And obviously, the hope when we're all done with this is that the games, when we spawn effects and despawn them rapidly, the game won't lag like crazy, like it's doing right now. So I just left under the Thunder Orb effect, which is the last one we were modifying. I just made it so it spawns 1,000 lightning bolts instead of just 3 per frame, just to demonstrate it. Because one thing we were noticing, you had to really like pay attention when I was playing, was every once in a while the game would stutter, and that's pretty much a no-go for a real-time application, right? Anytime the game freezes or stutters, you're gonna have a bad user experience. So, and the cause of that was, of course, the heap allocations we were constantly performing in the game. Even when it was just like 3 at a time over and over, those little micro stutters add up and feel very bad to play with. So I presume drop while will omit items from the view based on the condition from the beginning, but as soon as one fails, it keeps the rest. No, it just drops everything that does meet the condition. But in our case, if we have something that throws or returns, the moment it finds one, it will do that. So, yeah. Essentially, we're going until we meet a condition. Explain how I know whether things are heap or stack allocated. So, before, these were standard vectors. So standard vector is heap allocated, in case you didn't know. Because they can expand in size, and when they are initialized, they're given a small set of memory, and then if the amount of items inside gets too big, it grows. So anything that grows, you can't define at runtime, right? Like, that's the keyword, is can you define, do you know the size of this structure at runtime? Do you know the size of this array at runtime? You can see this allocates 544,000 bytes. That's on the stack. But a vector is only going to be like, I think, 24 bytes or something. And you're like, but wait a second, we can put like hundreds of elements in it. Why is it 24 bytes? It's because it's not stack allocated. The only stack allocation is the fact that this thing exists. So you can see a vector here, yeah. The vector is 24 bytes in size, which means the actual data, if we open it up real quick, is going to be heap allocated, because this giant mess effectively says I am going to create my types later on. This just holds information about it. I'd have to look at the template to tell you in detail what those types are. But anyways, heap allocation, right? We had a standard vector, and not only did we have a standard vector, but we had a standard vector of shared pointers to effects. So the moment you have pointers, whether they be unique pointers, shared pointers, or raw pointers, that data doesn't exist yet. It's just pointing to data. So how do you get access to that data? You have to request from the system, hey, I want some memory to hold this new data. You have to use the new keyword, which requests data from the heap. So system goes out, finds memory for space for that structure, whatever the size is, returns a memory address. It tries to return a memory address. It might not return a memory address. If it doesn't return a valid memory address, then you're kind of out of luck, because you're just accessing dead data. But ideally, it returns data you can use, right? And then that would give you a pointer, and the pointer can be casted to whatever you're looking for. Like in this case, it's our effect pointer, so it gives us a new effect, right? That data is now on the heap. It remains in the heap until you either delete it or end your program. If you never delete it, it just exists forever. So a container like a vector will claim ownership of that vector so that you don't lose track of it, right? Because if you just like have this in a loop, you're just going to create effects over and over, and eventually you'll run out of memory and your game will crash. So heap allocation is anything you allocate at runtime. Stack allocation is anything that is added to the stack before your program starts. So like everything known about like data types and all these members, these are all stack allocated. They're all going to exist at runtime. But heap allocation is dynamic memory that can be added during runtime. So all the members of a vector are going to be heap allocated because they don't exist yet. They're just holding values in memory. You're welcome. I'm glad I could clear that up for you. And heap allocation, when done excessively, gets really, really slow. And for a real-time application, it's super noticeable, because your game will stutter for a second, and then it'll stutter again, and again, and again. And pretty soon you'll be like, why is this game so laggy? Even though you're running at 60 FPS, if your game is micro-stuttering, that's a very bad player experience. Heap allocations are the devil when it comes to game dev. You really want to try to avoid them as much as possible. So that's why our solution was to turn it into a fixed size array. Fixed size array, or even what people call memory arenas, are very popular for more tightly integrated memory controlled game development, because it prevents you from doing any heap allocations. Everything is just running inside this closed memory loop. Any data you want is already allocated. You don't have to wait for that memory. Okay, so we're gonna drop while if we find anything that has a lifetime greater than 0. That's just a manual check for us. It's more like a sanity check. It should never fire. I hope it never fires. If it does, something went terribly wrong. What about something like static const vec x123? Would that still be heap? Could it be treated as stack? That would still be static const vec. The const is what's throwing me off, right? I'm pretty sure that's still heap allocation. Like, the vector itself, if anything, I will say at the very least, the members inside will be heap allocated. Not necessarily the vector. The vector itself is stack allocated. But if you're adding to a vector, right? It's going to start with that size, and then anything, well, I guess it's const, so you can't add anything to it. So while it should be, it would be heap allocated, but only at the beginning, right? Like, let's just make, we can test this. Let's say we have a class called test, and when it's constructed, it prints out construct. That way we know when it's constructed, right? So, the way to test this is, if it's going to be heap allocated, they would be created at runtime, which means everything else is already initialized. So for example, I can put a standard C out in my main, or not my main, but let's do in the construction of example, construct example, right? So in theory, the example class has to be constructed first, and then inside the example class is a standard vector. Although it's static, that might mess with things. Let me think about that. But it's a static member variable, so we're just assuming it's going to be created when the example class is created. Anyways, let me continue. Let's create 3 instances of test right here, right? In theory, actually, I think I can just type the number 3 here. I think that's how that works, maybe? Or maybe that's the size. Let's just do this. I think this is better. Right? So let's say we have that. Inaccessible? Oh, yeah. So, expected an identifier? That's weird. Oh, test vec. There we go. Okay. No? A member cannot have an in-class initializer. What? Const cannot have an in-class initializer. Inline? A member of const vector cannot have an in-class initializer. That doesn't make sense to me. Oh, you're right, it is inline. I'm sorry. Yeah, I didn't even realize I was just writing this like outside of any valid place. Okay, yes. I'm like, inline? Why am I... Oh yeah, I am inlining. So, in theory, if it was stack allocated, these should exist well before, like, anything else runs. But if they're heap allocated, then this vector gets created first, then the test vector will initialize these 3 in the heap, right? So that's like the theory, I guess. And we can also look at the amount of allocations too. The debugger lets us do that. So 3 construct. Oh wait, hold on. That's not what I wanted to test though. So let's do this. I think if we breakpoint on this, it will actually go to it, which is where we can see it, right? Okay, so here is test vec. This is like the line it should be running on. So where it gets constructed, right? Test vec has a size of 0. So at least according to this, test vec does not come with 3 items in it. Now, if we can make a const expression, maybe, right? I don't even know. Well, then these would have to be const, which I guess. Well, these have members, so I don't know how I would do this actually. These have to be like tests that are already defined, like well-defined tests. Like it'd have to be like these, which were already initialized, and then supplied inside of here or something, I think. And also that's static. So it looks something like this, probably. Which also would be const expression, which means it would have to be initialized. I think the whole the class would have to be const expression. Yeah, but like if you wanted to stack allocate, then as simple as just changing one thing, right? Then you have effectively the same thing. 1, 2, 3, right? And boom, you're stack allocated now. Because the thing is, these have to have a valid state, so you don't have to worry about dynamically allocating. Yeah. Because it's like, it can only be stack allocated if the size is known at runtime. Which, for a vector it is, but it's well defined in the sense of it's going to be initialized with no members. So we saw when it was running, it started with 0 members instead of 3. So it doesn't look like that forces it to start with 3 members at runtime. Yeah. Just things to learn, I guess, right? So yeah. But hopefully that clears up the concept of stack and heap, and you can play around with them more, of course. And Visual Studio does have a way to check allocations, right? So like, I guess I could show that really quickly here. You could probably do this in other debuggers too, but like, when we were allocating these guys as a vector at runtime, here, we can breakpoint here again, and I can just open up diagnostic tools, and we'll say, okay, diagnostic tools, we're going to enable heap profiling, which does make it really slow, so you have to make sure you do it only where you need it. Then we're just going to press F10 here, which means we're going to like the next line or whatever. It just did something. So now we're going to, oh wait, did I take a snapshot? Oops, I had to take a snapshot before I... Alright, rerun that. I did it backwards. Take a snapshot, and then run the next line of code, or run that line of code and take another snapshot. You can see here the number of allocations went up by 5 when we ran that line. So presumably the other two are very likely the vector itself, and maybe the internal of the vector, something else, right? But you can use that to track like allocations on the heap. But it's there now. I'm sure we could find it if we really looked, but like, this shows exactly what, oh yeah, this shows exactly what they were. So the container proxy, 48 bytes, allocated 3 times, so that's the container itself. Test had another container or another allocation. Yeah, so it's fascinating. Yeah, it's just good to see like, oh, this is how many so when I was testing this, I'm like, oh god, every time this thunder orb was emitting these, it was doing thousands of allocations. I'm like, Jesus. It was bad. It was really bad. Okay, so I just wanted to implement these counts so that we can excuse me, go back to here. These are going to be get foreground and background effects. we're just going to return references to these arrays now. That way, we want to return const versions too, because I don't want them to be modified through this getter. The only way to modify is to call add effect, and deletion will happen manually or automatically in a loop. So we're really restricting control of this effect system so that nothing else can touch the data by accident, even though I will likely never do it. Just have to be careful, right? Nishind, thanks for the follow. Appreciate it. Return foreground effect list. And then this will be background. Okay. So far we have those in place. So next is to up this count whenever we call add effect. So we're gonna go into Adventures in Listoria, and under add effect, where we return... So if we return true... Let's see here. If we get to here, we haven't found... Okay, so this is saying drop while the lifetime is less than or equal to 0. So if it returns true... God, I had to keep thinking about the logic for drop while. While it's false, keep iterating. As in, like, keep going while it's false, right? Or while it's true? Gosh, I keep forgetting. No, yeah, keep dropping while it's true. So while it's true, find or dead slots? Skip dead slots? No, I think we have the opposite logic here. We wanted to return true if... We want to skip if it is alive. Yeah. So the lifetime is greater than 0. But we wanted to return false. Yeah, when we return false, I is less than 3 is true. We return false, it actually returns it. So then we take 1 to add it to the effect. So this is where we add the effect. Active foreground effect count should go up. Or, well, it depends on if it's a background effect or not. So if background effect, added to the background effect count, otherwise add to the foreground effect count. So it's gonna look like that. Kinda don't like it on 2 lines or 1 line. We should also assert here, if it gets too big, then we're actually going to complain. Like, it should never go over the limit. I've also been hard coding this 1000. I have a feeling this might change in the future. So I'm actually going to fix it now while we're here. I'm going to find all instances of this, and I'm just going to replace it with effect limit. Because I really have a feeling we might be changing that in the future, and I don't want to hard code it. So we're going to put that in all caps right there, and we'll just define effect limit at the top of this file. I can hard code it up here right now, but if I ever change it, I want it there at least. I wonder if I could put a number in a using. Wouldn't that be cool? I don't know if that's possible. I don't think I've ever tried that. Yeah, I think it only works for types. Anyway, we'll do a define. Like so. Okay, that way, if we ever change it, we can just change it up here. Because I'm tired of, like, typing it out manually, and what if I change it? Then I have to change the number basically everywhere. So I'm kind of, like, running into this trap of I'm gonna have to do more work in the future. So if get active background or get foreground effect count is greater than effect limit, or background effect count is greater than effect limit, we're actually going to crash the game because this shouldn't be happening. So error, we'll say warning, effect count has exceeded the limit of whatever. Effect limit. Okay. And I like to put this should not be happening, to make it very clear that we should not be here. And again, this should be unlikely. I should also specify unlikely for our checks here too. Actually, there's no conditional here. There is an error here though. Why? No instance of format matches the argument list. These are... oh, these are... wait, what? Those shouldn't return arrays. Did I mess up? Oh, I'm not done. That's why. This should be get foreground effects and background effects. I think I put the word active though. I don't know if I really want to include the word active. I did say that was kind of redundant. Get foreground. Oh, I just didn't finish. Yeah, I wasn't done here. So we do that. We do that. Okay. I think we're okay now. Ooh, effect limit is not defined here. It should be, Well, that's kind of annoying, isn't it? Let's put it under defines. That way, if we don't know what it is, we can just include that defines. That's literally what the header is for all of our defines. I'll just put it up here. Okay. And if it still doesn't know, we'll include it. It looks like it knows now, so we're happy. Okay. We don't have much more programming time left for the day, but let's finish up what we can here. These now are going to use the get foreground effects and get background effects functions instead. And these will be const. Also, this shouldn't be hard-coded as 1000. Okay. So far, so good. Let's see where we're at with the build. This has been a very long refactor, but I feel like we're closing in. We're getting close. Oh, we do have to decrease the effect count when they expire. So let's go to the update effects function. So inside update effects, if during this effect tick, it goes from having a lifetime to having no lifetime, we essentially need to decrease it at this point. So you can see here we call standard visit to do whatever update function we need to. After we're done with that, presumably the lifetime may have changed. So we can then say if effect effect lifetime. Oh, we actually have effect data here, so we shouldn't need to go into effect itself. We just say if effect so we have to determine if it was alive before and if it's alive now. So we'll call this like previous alive state. Previous alive state. And it'll either be true or false to indicate if it's alive or not. But I guess that's not very clear, so maybe a quick little enum inside of here for that. Ugh, God. That just indicates alive or dead. Maybe we'll make an enum class to a bool. That's weird. Lost connection for a second. Interesting. Yeah. So if let's do this. Effect.lifetime is less than or equal to 0. This was a pointer, so dereference. Then it's dead, right? So that was the state it was previously in, otherwise it's alive. And then we check if effect lifetime. So then we check the state again, new alive state, and compare the two. And if new alive, well, we don't have to compare the two, we just say if new alive state is equal to dead, well, and it was previously alive, right? So if the new state is dead and the previous state was alive, which means they have to not be equal to each other, but what if it's alive? That wouldn't work either, right? So no, because it's either gonna be one's alive, one's dead. What if it went from dead to alive? That wouldn't really make sense, would it? But that state should be impossible. Maybe we should actually crash if that ever happens. That would be funny. Wait, no, that's not true. Hold on. Yeah, an effect should never come back to life. It can be resurrected in the update function, but it cannot resurrect if it was dead. So that would be a case to make sure of. So it'd be like, yeah, I would want to check both versions. So if new alive state is dead and previous alive state was alive, then well, it's died, right? I also want to read it backwards, I think. I want to read like the previous state and then what the new state is. And so if this occurs, this is when we set or decrease the count. So this isn't under Effect Manager, but this is a friend class to Effect Manager. So it does have access to all the members. So we just set the active, in this case, background effect count down by 1. We'll probably do some bounds checking as well. If we're doing manual counts, it's very important we make sure that they are exactly the way they are. So doing all these checks assures us that we're not like breaking state in unexpected ways. So if we go from dead to alive, something terrible happened. We'll say warning, effect in slot. So we don't actually store what slot we're in, so let's actually do that now. Size T effect slot starts at 0. We'll reset it for the next loop. And we'll increment it by 1 each time. So all this is going to be the same in both of these, so I may turn some of this into a lambda, or maybe all of it into a lambda. Yeah, probably. And just like iterate through these separately. Yeah, well, no, because this has to change, so we would have to supply that if we want to change it. I mean, it's still possible. Yeah. We'll do that after. Clean up after. So, yeah, let's pass an effect slot into both of these as reference. Effect slot. Can you make that sort of defensive check only apply when you're in debug mode, but drop it when you go into production mode? Yeah, so you'll see I'm using this error macro here, and this is actually a really good thing to do if you're going to make a logging or error system. Because when it's time to release, right now in testing, we want it to crash, right? So we go to error log, and error log actually throws. If we just comment this out, we can also just remove all the debugging messages if we want to avoid it spamming the console. And bam, we have a release build where it won't crash, and whatever happens, happens. So this is a really important thing to do if you're going to have long-term debugging in your game, making a way to differentiate between an easy way to control every call or console output. And then we have a debug version that doesn't throw for pretty much everything else. So we have full control over when or how we want to actually crash the game. Which is why I'm so like, I put these everywhere, because I know I can later get rid of them if I wanted to. Some people even go a step further and have like debugging levels. So if you have a debugging level, you could be like only log level 1 or level 2, level 3, like critical, right? That's usually a common paradigm too. I didn't find it particularly useful for myself, but yeah, just nice little things to keep in mind, I guess. So this is, and since it's a macro, it's all done in preprocessor, so it's not like this code will be hanging around or anything. This will just become like a no-op, so the compiler will comment this out or get rid of it. Also, I don't know why I'm doing that. Warning. Effect in slot whatever. Because I want to know what slot it's in for easier debugging. Also, another thing I do with these messages, if you just took a quick peek, is I store the source location and dump out the stack trace. So this information is very useful when debugging, right? Because then you know exactly at what line that log or error was called, and you have a stack trace to follow back. So that's a very useful function to have. I'm trying to see where my log is so I can show real quick. Very useful tool. That would not be the log. Okay. So you can see here, like, it always gives me a line indicating where this message took place, so I can always trace it back. And then if we get an error, it would show up an entire stack trace. I don't have errors here, but if it did, we would get the entire stack trace right there. That's a very nice feature to have too. Okay, so effect in slot whatever. This is a effect slot. Has resurrected. Sounds so silly. And yeah, this should not be happening. So the other case we're interested in is if the background effect count or the foreground effect count end up out of bounds. So that would be either below 0. Actually, it can't go below 0, it's a size T. So let's say it's above the effect list count. If it underflows, it goes back to like the 4 billion whatever that's supposed to be. Actually, I think it's way more than that. I think size T is 32 bytes, at least on this system. So if... Let me just actually use the effect manager's functions here. If foreground effect count or background effect count is greater than or equal to effect limit, get background effect count, then we have a problem. Just say warning, effect count limits out of bounds. Out of bounds. And we'll say foreground count and background count. And then provide those two functions again. Oops. Background effect count. And we could even say what the actual limit is supposed to be. Limit. Whatever. Effect limit. Yeah. All sanity checks that we need to make sure of when we're doing this, because there are a lot of potential problems that could arise if this goes haywire. Like, this all has to be kept very much in check. So, this should also be very unlikely. So now that I've written this, the next thing I want to do... Did I mess up somewhere? Let me see. There's a parenthesis here. I didn't close this. This was for the standard format. It needs a semicolon, or I delete the curly brace, which I thought I did earlier. I think I did that for this guy. Let me see. Error does not have a parenthesis. Okay. So now it's matching there. It's still complaining about standard format. 1, 2, 3, 4. 1, 2, 3. Where'd I get? Oh. I thought I messed up one. Okay. So we should be okay now. 1, 2, 3. 1, 2, 3. I think that's correct. Aura editor. For sure. Welcome, I like corn dogs. Something is not clicking with this. Effect list is undefined. Oh, effect list? It should be effect limit. I don't know where I got that from. Okay, and then we can quickly turn this into a lambda, and I think I'll call it for today. So this lambda function needs 2 parameters. One is... Let's see, so this is... run update. Run effect update. It's going to accept a list, so that's going to be standard array effect data effect limit reference array, and the second parameter should be the effect count. So that's just a size T ref effect count, and then we need to pass in this instance for everything else. We can then move all this into here. I would even argue the effect slot can go into there, assuming the for loop goes, yeah, so all this moves into there. like so. And then what we're left with is the effect itself coming in, which is right here. So that all looks good, and then we just call that function now for both versions of effect update. So now we just provide background effect list along with the effect count update, which is effect manager background effect count. Not that. Active background effect count. And then we provide another one that is the foreground instead. And now we have effectively made it for both the background and foreground effects. So it will run all those checks for us and still do the standard visit and update every single effect. So I think we're in a good spot. We're still not compiled yet, but we're getting closer. But I'm gonna go ahead and do a active background effect count undeclared identifier. Did I mess something up here? These are in effect ref. Oh, I see. They should be under effect manager incrementing these, which I don't think this is a friend class of that. So that will have to wait. Okay. Yeah, we could make an effect class or a friend class. I guess we're at the point where we can be a little less restrictive and say friend class effect ref. That way it has access to our stuff. And then inside of Adventures in Listoria. Oh, this is actually for AIL. Never mind. AIL does have access to it, but they're static. Right? So it should be effect manager. Counts increase and decrease. And these functions should be called like so. So I just missed some static calls, that's all. Okay, that makes sense. Okay, cool. So let's go ahead and commit this for now, even though it doesn't build. This is a good checkpoint. Oh, my test project 1 got added to the... I'm actually gonna delete all this. We don't actually want a project 1 in our folder. Did this not delete? Doesn't want to delete. I might have to do this manually. I didn't mean to make my test project in here. Get out of here. Alright, so that's gone. Should be gone. And then I think that's everything. So this is continue implementation or continue refactor of effects. So everything's looking pretty good. We're getting closer to the ideal point where the effect system is where we want to be and flexible enough for us to use. So we still got a lot of work to do, but we're getting closer. So hopefully tomorrow we might actually have a buildable build. That's the hope anyway. I expected this to take at least like 2 days, so with the amount of code we've got left to do, I think we're getting close. So a lot of good progress today. Anyway, oh wow, I don't need this anymore. That's old. For those of you that tuned in though, thank you for coming by today, and we'll see you next time. Hope you all enjoyed. Yeah, always a learning day. Thank you, Tiger. And for everybody else, have a good one. Bye-bye.